You start with the cross, what multiplies to AC and adds to B, and what is, yeah, negative 30. B is negative 7. Ten and 3, where the 10 is negative. So what are we going to do with that? Why do we care about that negative 10 and 3? That's right. You rewrite the negative 7x.
Wait a minute.
And then you bring down the first and the last term.
I would like you to know I'm stupid and don't worry about it.
You're not stupid. Okay. What's next? I hear all of you. Thank you, all of you. 2x. What was the GCF here? Data. Oh wait, did I do something wrong? Oh, this is a minus 5. It's called error analysis. It's good for you to figure out where I went wrong. Okay, so that was a quick review. We're going to be using this again today. What we're doing today is dividing again. Yesterday was dividing, but everything was already in fraction form, and really we were just canceling out. It's technically division because there's the fraction bar. So there are two types of problems today, right? One where there's just one fraction, and one where there's two fractions being divided. So we'll start with this one first. What I want you to do before even that is just make a list on the side of all of the factoring methods we know so far. What's the first one you should always check for no matter what? Okay, GCF. And then after that, we learned grouping. So anytime you have 4 terms, you do your grouping. After that, the AC method. And for the last couple of days, I've been talking about AC methods short and long. I'm going to stop because it's been confusing people, and they've been doing exactly what they start doing when we introduce a shortcut and forget when it applies and when it doesn't. So I'm going to stop talking about that. But if you remember every time, you're welcome to keep doing it. And then the last one, I'm going to shorthand it as DOS for difference of squares. So you're going to have to decide each time which factoring method applies. So for this first example, in the numerator, which it's GCF, right? Now, how do you know it's not difference of two squares? Because I have two things being subtracted. They're not perfect squares. You can't square root them. The bottom is. So the bottom is the DOS, the difference of squares. So in the numerator, what is the GCF? 10. 10. 5 is common, but it's not the greatest thing in common. So we factor that out. We put the leftovers in parentheses. Difference of squares on bottom, that's where you square root each thing. You make a minus version and a plus version. So on the bottom, it's x minus 12, x plus 12. Yep. Strangely familiar. Yeah, because once we get it in factored form, it looks just like what we did yesterday. That's no big deal, right? Okay, so now we layer up a little bit. it's not bad. Thank you. It's this term. I told you about my college professor that made perfect circles, right? Yeah. I was like entranced every time he was making. We studied geometry, the history of geometry for like a couple weeks. All day he drew circles. Right here, I have a fraction divided by a fraction. Whenever you have that, you need to multiply by the reciprocal, but what's our shorthand thing to call that? KCF, right? Keep, change, flip. That means you keep the first fraction the same. What does the change part mean that you do? Change to multiply, and then you flip the second fraction. So here's how that would look. So I'm going to keep that the same, change to multiply, flip.
Wait, they cancel out, right? The x tens. Yeah.
They do, but first we need to factor. The 21 can factor. The 3 is 3 times x. Notice how I put the x plus 10 in parentheses, right? Because the plus means they go together. They're a group.
Correct.
Do you remember our bad math?
I remember bad math.
Let me show you.
I remember bad math.
Put your eyes up here for bad math. I want everyone to watch it. I'm going to put it in black for evil. You ready? Did I say something wrong?
I think it might put green for the blank there.
Did I say something like wrong? Do I need to go to Urban Dictionary later and figure out what I just said? Do I? Oh, y'all, I was not. Come on. Please. Let's get back on track. That's not even nice. Don't even joke with it. Okay, you ready? Okay, let me do not black then. Sorry. Y'all just messed me all up. You don't know what I meant. I'll do green for puke. Green for puke. I didn't say anything wrong there, did I? Green for puke. Are we ready for the bad math? Are we ready? All right. Okay. Let me tell you why. Let me tell you why that's bad. It's bad because you can only cancel factors, which are things that are being multiplied. This x on the bottom is not being multiplied. It's being whatted? Added. That's a term. It's not a factor. I did. So you can't cancel things that are being added or subtracted. You can only cancel things that are being multiplied by other things. So here we go. You can't cancel that x all by itself, but you can cancel those groupings, right? The x plus 10s. Because as a group, it's being multiplied by other things as a group. So therefore, it can cancel. And then what else cancels? 3. And so then we're left with x over 7. Okay, that was good enough. Yes. I factored it so I could see what would cancel. I broke it up into factors. Okay? Yes, that's right. And if nothing had canceled, I would have just put it back to 21. Yeah, like if you just had 3 over 21. Yeah, as long as you recognize they had something in common. Kind of. So for the next, I'm going to give you a minute to do these problems by yourself, but I want to get you just set up knowing what factoring methods for each one. So I want you to take these notes down. In number 1, what factoring method do you need in the top and bottom? AC, right? AC on both of them. What factoring method do you need at the top of number 2? GCF and ACF. Oh, ACF. That's not even a thing. I just said it. GCF and AC.
Sorry.
And what does the bottom need on number 2? Greatest common factor. We're going to talk about factoring methods on 3 and 4. That's fine, but what else do you have to remember on 3 and 4? Keep, change, flip. So what does the numerator on this one need? AC. What does the bottom need? GCF. What is the, what's this one on the top right? X squared minus 4. Difference of squares. What about x plus 1? You just leave it. It doesn't follow any of the factoring methods. There's nothing you can take out. It doesn't match any of the other things. You just leave it alone. It's just parentheses. So there's nothing. Not applicable. Oh, there's a typo I need you to fix on your worksheet. Are you ready? Right here on number 3. X squared plus 2x plus 4. It should be a 4 in the middle. Right here. So that highlighted part, that should be a 4. Yes. Four on the top, what is that? I messed up. What's the bottom? Nope. Because 4's, yeah, 4. And then, what's this, what are these two both? AC. No GCS. Okay,